Brainstorming rules. Rules of brainstorming. No judgment of others' ideas, no judgment of your own ideas, no negatives when you're brainstorming. Zero negatives. The negatives come later, getting all the ideas out. You don't want people to limit their ideas. You want all the ideas on the table. You want all the cards on the table. You want people to be free to express their ideas and not be criticized, so which would impede them. It would hold them back. So you want that free flow of ideas. One of the best techniques of brainstorming to encourage that, write your ideas on a sticky note and put the sticky note on a whiteboard, white sheet, a poster or something like that. Collect up all the sticky notes. So people write a sticky note and they put it in a pile. Write a sticky note and put it in a pile. And everybody's doing that. You get to build on the ideas of others. So if somebody has an idea, say, I like that. Here's a twist on it, or a little different tact, or something similar. Wild ideas, wild and crazy ideas. Which a lot of times that gets humor going. Even the Star Trek transporter for transportation, ha ha ha, very funny. But it gets people loosened up. We want a high mileage semi truck to haul cargo, and somebody might pipe up a horse and wagon. Infinite mileage, feed it grass, biofuels. Well, of course, it has other limitations. Everybody knows that, but it gets the humor going. Humor is creative. I mean, there's something unexpected that happens in humor, something unconventional. So wild ideas, go ahead and welcome them. Go ahead and stick them up on the board. People might, it starts getting fun now instead of being a chore. A diverse team of people. Now, you've been in organizations maybe where the boss says, we need a brainstorming session. Somebody comes up with an idea and says, no, that's not going to work. No, that's not going to work. That's not a brainstorming session. That's just some guy who's trying to manipulate the conversation. To get a true brainstorming session, no judgment of your ideas or anybody else's. Diverse team, the biologist on the engineering team to prevent birds from flying into windows. Have a facilitator to keep everybody on track and to tell people, no negatives, remember, and keep everybody involved. So everybody write down 10 ideas. You don't have 10 yet. You don't want to pick on people, obviously. But on the other hand, you do want to encourage them. We really want to encourage your ideas to come out. The best idea to float to the top. Now, NASA had this problem in the 60s. They had plans to build a super huge rocket to take men to the moon. And this super huge rocket they didn't know how they were going to use it. They were either going to launch a craft that would leave Earth, go to the moon, land on the moon, come back to Earth, and then take off from the moon, come back to Earth, and land back on Earth, which would have required a huge, massive booster. And another plan was to send people up in a craft to a moon shuttle craft. So they would transfer from the Earth orbit craft into the lunar craft, and that lunar craft would fly to the moon, land on the moon, lift off from the moon, come back to Earth orbit. Then they get in the smaller craft and go home. But the lunar orbit rendezvous, the main weight of a craft is in its life support. You have all the facilities you need to keep the astronauts alive for about a week on their round trip to the moon. and lifting off from Earth and the round trip to the moon is going to add most of the weight of the craft. The landing on the moon and taking off from the moon can be a very small craft. It doesn't have to be very big at all. So the engineer who proposed it, he had to go through a lot of resistance, make a report, send it to the NASA administrator. He had to get the backing of some managers, and they wrote a 20-page report on why this is a better idea, and to get men to the moon. It was the idea that was adopted eventually on how to get there. So they didn't have to build the Jupiter rocket. They stopped at the Saturn V. They didn't need anything bigger and better than that. So people need to be sold on a new idea. Resist change, and I don't know why we do that. Resist the status quo. Don't boast, don't belittle current practice. So now you're presenting a new idea. You're selling it. You've come up with something really creative. Now you got to sell it. Don't belittle current practice. It rests on its merits. Be professional. You may be judged solely by your presentation. Be prepared for criticism. Anticipate objections. The audience may be more expert than you. Scientists are trained to be skeptical. Prepare yourself well. Don't be discouraged if it's not accepted. But also a counter to skepticism, by the way. Look, we really don't know until we try. Let's build a prototype. Let's not just thumbs down immediately. Pilot it, build a prototype, test it, see if it works. Okay. Quick tips: make the strange familiar and the familiar strange. How would you explain a toilet to somebody from another culture? So this is not your conventional American toilet. It's unconventional to Americans, that is. Abstract to the essence. The core function of a lawnmower is to reduce the height of the grass. So you could use a CO2 laser to level, spin it around and level all the grass. Now that's a bit impractical, and the ground isn't perfectly level, and all those other problems, and plus the fact you might blind somebody. So not real impractical, but it's to reduce the height of the grass. How are you going to do it? Can you get the grass to stop growing at a certain height? Can you get a new strain of grass that only grows so high and you never have to mow it? That'd be kind of cool, actually. Okay. Separate the functions. So you have two problems. A 2-liter bottle has to hold pressurized liquid, one function. It's also got to provide another function. It's got to provide access. If you make a water bottle rocket, for example, project, you've got several functions. You've got to produce the compressed air. You've got to interface it with the bottle pressurizing system, and a platform. So you've got a platform now, a pressure gauge, which may be integrated into your pump, which, obviously that might save you some work there. And then you have some way to release, some way to hold the pressure while it's building up, and then a way to release the pressure, or release the bottle so it launches. So you've got several systems going on in that. So separate out the functions. How are you going to solve this one function? Then how are you going to solve the next one, and the next one, and so on? Look for solutions to similar problems. So Velcro might be analysis to burr sticking on dog. That's how Velcro was invented. This guy had a dog, and he was picking burrs off them, and he's noticing how well it stuck to the dog's fur. And he said, well, what do they look like? Well, they look like little hooks, like Velcro. He said, oh, let's see if we can manufacture this stuff. And Velcro was born. Overcome hidden assumptions. Did you assume a door opened out and not in? Build on the ideas of others too. So a hidden assumption for an automobile might be that a car has four wheels. Well, can you build a three-wheeled car? We have three-wheeled motorcycles now. They're working pretty good. They're becoming very popular. Much more stable than a two-wheel, safer. Why not a three-wheeled car? Summary. So the creative process is often stifled. We want to unblock it. You want to integrate the systematic engineering goals, make a widget that does this, that, and the other thing with wild and unpredictable creativity. So you can get the really good solutions, the better, cheaper, faster solutions. Use brainstorming, 4-stage model, and that's preparation, incubation, illumination, verification. 4-stage model. No premature judgment. Use the rules of brainstorming. Present creative solutions to skeptics. Learn how to do that. Use some of the tips from this chapter and other tips from chapter 5 of your book and this handout and this video. Okay, end of slideshow, end of this chapter.